Hello and welcome to Uncle Data, and this year I'm collaborating with PyCon Lithuania to bring you conversations with keynote speakers. And today I'm joined by Gábor Szárnyas.
That's right.
Nice. And we're going to talk about the story of DuckDB. Like I guess most of you know about this lightweight analytical database and why SQL keeps thriving, where everyone says that it's gonna die sooner or later. So hello Gábor. Nice to see you here.
Hello. Thanks for inviting me.
I guess like the interesting thing for me how you ended up at DuckDB Labs.
Okay, so interestingly enough, my personal career reflects a bunch of industry trends. I studied SQL and databases as an undergraduate, and I thought it is interesting, but it's very technically backwards. You could feel that it's something that was invented in the 70s and the 80s. And obviously, as a student, I was craving some novelty, so I looked into NoSQL databases. I got really deep, especially in graph databases. And I also looked into doing things distributedly. In 2010 and 2012, this was all the rage. If you had a single machine that was probably not sufficient for your workloads, so you had to build a distributed system. So I did a distributed graph query engine. That was my master's thesis, and that turned into my PhD topic too. And then a bit later, I moved to the Netherlands to work on database benchmarks, and I ended up at CWI. That's the Dutch National Research Center for Computer Science. And I was still doing graph work there, but obviously being in a database research group, I had to work on my SQL skills a bit. I had to understand more how databases work in general. And while I was doing that, in the adjacent office, Hannes Müleisen and Mark Rasfeld kept working on a system called DuckDB. And DuckDB is the polar opposite of what I have been doing so far. So compared to a distributed NoSQL system, DuckDB is a single node SQL system. And initially I just started using it in my research, but it started to make more and more sense to me. I could see how the scalability works on a single machine, and I could see how SQL works, especially with some of the additions that DuckDB introduced. So it all started to click. And when they created a spin-off company, I joined them a bit later in 2023. And I work at DuckDB Labs now for the last 2 years.
Nice. So, like my initial thoughts before I tried DuckDB is like that it's SQLite for data.
Yes, that's a very accurate characterization.
Okay, so like though like what I also like is the CLI option. When just can query your files and whatnot, just like or you can connect to your S3 in a way like credentials and just query your Parquet files from there. Like makes everything like run smoothly and fast. Just using your local machine. So my question would be more on the topic. So like you mentioned also distributed computing. And now we see that people are converting back to the local processing. So why do you think that's happening?
I think there's a lot of periodicity in IT, and this is one of the instances when the pendulum is swinging back. The main reason is the advancements that we had in hardware. So even though Moore's law is kind of dead, there is a lot of optimization that is going into modern computers. We get better disks, we get more memory bandwidth, we get CPUs that maybe have the same frequency, but they have more cores and they have more clever instruction sets. So if you build software that can exploit that, you can process more and more data. Now, the real question is whether if you have a faster database, isn't it canceled out by just having more and more data that is keeping up with the improvements of your system? And what we have observed is that actually systems are getting faster than the data sizes increase. So there have been a bunch of studies about that in the last year, and people have shown that even the big cloud data warehouses like Amazon Redshift and Snowflake, the queries that they run 99.9% of the time are actually not that huge.
Actually, it makes sense, when you think about it, if you're using, some filter pushdowns and you're running, your queries on Parquet files, it's quite efficient and generally you're scanning very little data. So I guess, that's where also we can talk, we can cover a topic about the let's say open table formats, right? Because they also make some things or like optimizations, how they store things, happen as well. So I know that, you mentioned, before we talked about the roadmap of DuckDB, so maybe let's start with that as an introduction, and from there we can go into different formats. So.
Okay, so I think this is a really good point, and I will actually talk about this today at PyCon Lithuania. And the main topic is that data is no longer just a bunch of CSV files. If you have CSV files that are sitting on the disk and you want to query them directly, this is doable, but this is widely impractical. And it's much better to have something like a columnar format where you store the data by column, and you can apply some sort of a lightweight compression on it, and you can store it in a binary format with some lightweight statistics like min-max indexes. And this is a seemingly simple idea, but if you apply it in your system and if you build your system from the ground up to work with this format, you can do all of these things like predicate pushdown. You can just select the given columns that are important for your analysis. And it turns out that this gives you a huge advantage when it comes to dealing with big data, because you can most of the time just ignore 90% of the data that's sitting there, and you can deal with the 10% with the available resources.
Since you mentioned, like about columnar formats and actually, for like actually using relevant columns, what's your thought about people actually, like using, select star and these kind of things? Like, I guess it's one of the reasons why actually some of the engines actually are not possible, like they're not capable of like processing the data that fast, just because, people are not mindful of what they're actually selecting.
Yes, this is something I experience day to day. I am just getting a bit lazy and doing select star, and there is a noticeable lag in the result. There is a noticeable time when the system is preparing you the result. I think this is something that needs a bit of retraining for the users. You have to be taught to only select the columns that you need, or if you are in the exploratory phase, do just a limit 5 or do a sample of your table.
It actually makes sense. Like I think one of the things in one of my previous companies where people learn not to use select star is BigQuery. They use select star on everything, and then you suddenly see, that they're scanning like 5 terabytes of data, and like doesn't matter that you're limiting, but just like scans everything, and then like the bill is like huge, and like everyone is like, why is happening? Like, yeah, you're selecting everything. What do you expect? Okay. So I guess one of the other things what I actually just figured out now, like, so yes, DuckDB can store its data as like, its own internal format, right? But what do you feel about people actually using it as a like processing engine? Because, most of the examples I noticed on LinkedIn when people are sharing, they're actually just, processing the data which lives outside of like their machine, or like in a different place, not connected to DuckDB. And the DuckDB as database is very used very little.
Right. So indeed, this is important to distinguish between the two. And maybe this is something that I could explain to our listeners in more detail. DuckDB has its own native on-disk format. This is also a columnar format. It uses lightweight compression, and it's a binary format. And it has been designed with 2 key features compared to other formats like Parquet. One is updatability, because DuckDB is a database. You need to add the row, delete the row, maybe just adjust one value. So the DuckDB data format supports that. And the other advantage that it offers compared to Parquet is that it has more granular statistics. So if you need to do something that's not just a scan, an aggregate, or a filter, then the DuckDB format has statistics that are fed to the join order optimizer, and that yields better query plans. Now, if you don't need either of those, if you don't want to update your data and you don't want to run complex join heavy queries on it, then running the queries on Parquet is pretty much the same performance as running on DuckDB's own format. And because you can skip the entire ingestion step of loading from Parquet to DuckDB, overall, it's actually going to be faster.
I didn't thought about, the internal join optimizations that were actually done. So I guess, like you have implemented almost everything what Parquet kind of has, like with with on top, have more details, which allows to do like better joins. So that sounds like a good thing. Though one thing what I actually was thinking or like limiting me in some cases when I was doing it is that it doesn't allow concurrent writes, right? Because it locks the state, and then can't do any changes. And I guess it actually follows its own internal, I guess, logic. Like SQLite also doesn't allow that.
Right. So we did follow SQLite's lead in this regard. So you cannot have multiple DuckDB processes connect to the same DuckDB file. And this was a conscious decision to keep the system architecture simple. But what we can do is that you can write concurrently from a single DuckDB process. So if you have one way of collecting all your writes and then doing it from a single process, DuckDB can actually do that. And it can do so using transactional guarantees. So you have all the ACID transactional guarantees that you would expect from a database or data warehouse system.
Okay. Didn't thought about that. Nice. So, like, I guess, like, follow-up question, like, we talked about different formats, and, I mentioned, that I was seeing people doing, like, just data processing using a DuckDB as an engine. So, also noticed that if I'm, like, there was one guy, I don't want to, mispronounce his name, and also, I'll try to add it into the description where his post, where he tried to build a multi-engine data stack. That's the most interesting part for me, in general, how to combine, data processing locally or like, on a single smaller machine, like, for, let's say, development experiences, right? And then, if you needed to scale it out, you either run it on some, I don't know, Snowflake, BigQuery, whatever, and just balance it out, because that will also, reduce the costs, because usually, the hardware, like just to run your DuckDB will be lower compared to run your workload on, let's say, SaaS kind of a DB, right?
Right. So I think this is tying into two different topics. One is that we have all these wonderful cloud data warehouses like BigQuery and Snowflake, and they have a good user experience, and then they are fast, but they store the data in a proprietary native format that is in their own object storage, and that's difficult to access. So if you want to do something like running a machine learning job or a data science job on one of the data sets, you probably will end up writing a convoluted extract script that gets it out from the database, puts it in the hands of the Python script, and then maybe at the end of it, you have to write it back to the database. So I think this is problem number one. And problem number two is that we have these systems which have gotten, well, if not more expensive, they definitely haven't gotten cheaper. So running these systems is something that will be rather visible in your monthly cloud bill. And this is where data lakes come into the play. So data lakes are popular because you can take the data and write it with your operational cloud data warehouse, and on the same data set, you can operate with maybe just a query engine or another Python script. And that makes the whole collaboration a lot easier, both from a technological point of view and also cheaper.
Yeah, I was aiming also, like to follow up later, so let's say we have an Iceberg catalog, right? Like if I'm not mistaken, all of the major, like providers are currently supporting like Iceberg catalogs. You can, store your Iceberg tables, let's say in your S3, GCS, whatever. And then, you can point your vendor, to the same data store, right? To actually, understand where the data sits. And then actually, if you know that, you can actually point your DuckDB in that way.
Yes. So all these open table formats are trying to ensure that you have an experience where even though your files are just Parquet files and object storage, you see them as actual tables. You can do transactional updates on them. And then if you start adding the catalogs, you basically have a full-fledged database with access control, with schema migration, and even other features that databases don't generally do, like you can handle snapshots and do time travel queries. And DuckDB is also moving into this direction. We have support for both Delta and Iceberg. Currently, this is a read-only support, but in 2025, it's very high on our roadmap to extend the support for these formats and add write support and other features.
Ah, nice. So technically, if I would want to build something like that now, right, I could do the writing part to Parquet, as an example, right? And then I would need to actually transform it to actual Iceberg table to insert it with some different process, at least at the moment.
Yes, at the moment you have to do your Iceberg writes with some other means. You can rely on PyIceberg or you can use Spark, but this is coming very soon to DuckDB.
Oh, nice. So I guess it's one of the features that actually people dealing with very different workloads, from time to time, actually is one of the key components for them actually to make it more cheaper as well as scalable and also, locally testable in some cases.
Yeah, so of course, Iceberg and these data lake formats were kind of conceived in the environment of the cloud and the object storage, but there is nothing stopping you from running it on your own disk. And there is actually one thing that's rather interesting. If DuckDB gets support for writing Iceberg or writing Delta, that will solve the concurrent access problem too, because then you can run it on your own laptop and you can have multiple DuckDB processes writing to the same data lake. So that's actually a feature I'm quite looking forward to.
Oh, okay. I didn't even think about it. Like now, like in general, I'm thinking even now that it would enable like tons of other things. Like, you can even run stuff on Lambda, very, very lightweight, right? And then, when Iceberg is open, just like flush it down properly, do whatever you want in that Lambda. It's going to be even cheaper than actually, running things later. No, my God.
Yeah, and this is already happening. So there are already Lambda implementations for DuckDB. People deploy it, but currently it maybe needs a bit more of a hand-rolled infrastructure code because you can only write Parquet files, and that is something you need to take into account.
Yeah, but nonetheless, I guess, in the near future it's going to be solved, and that's going to solve most of the engineering points. Now, talking about engineering, right? So you saw, like you mentioned that your experience was about the databases, right? Like you were working on the internals, you know them well. So my question, have you noticed any changes in development or like data engineer patterns, how they work or operate with databases? I know it's a tricky question.
It is a tricky question. So I think I see most of the changes around these binary formats and data lakes. One of the changes that's easy to point out is the move from the ETL pipelines to the ELT pipelines. So in ETL, extract, transform, load, you extracted things from the source system and you had some infrastructure to do the transformation in the middle, and then you loaded it into your target database. And people figured out that those scripts basically do data processing and they can be a bit brittle. So how about loading the data into the target system, which was facilitated by loaders that are a bit more lenient than the loaders of 20 years ago. And then you can do the transformation within your system with SQL, with the safety of having a database and having transactions to roll back your queries if something goes wrong. So I think this is a big change, and this is something that DuckDB fully embraces. Other changes are, I think, out of core, so larger than memory processing has become quite normal. All of the major systems do it. And of course, you can still fall off the cliff. You cannot do 10 terabytes of data with 4 gigabytes of memory. But there are quite a few workloads, especially aggregation-heavy workloads, which can scale really well. And oftentimes, it's not time critical to do your reports in 5 seconds. So it's not worth spinning up 32 Spark instances just to do that report. And sometimes you can just do these long-running batch jobs overnight with a rather resource-constrained environment. And this is simpler operationally, and it's just something that makes sense for many organizations to do.
I'm thinking now, since you mentioned about like the more running, longer running jobs, for this, like, do you think, that one of the reasons also, why people are thinking of options of processing data more locally, that also has to do with it, right? Because it will, like lower resources, you have a lower like CPU instance, like lower, let's say EC2 instance running with this. It will save money and we'll get that data around similar SLA, let's say.
Yes, and I think one of the things that we say with DuckDB is that you have a MacBook Pro likely on your desk, And that's equivalent to a reasonably powerful EC2 instance, and you already paid for it. So if it's sitting on your desk, it's not really useful to just make use of it as a glorified terminal. If you have the data at hand, you can probably do the data processing, and often much quicker than in the cloud.
Okay, that actually, I was like also thinking, like in case, like when you're working at a bigger data project, how to, and your costs go a bit higher, then what happens, right? Management comes in and says like, oh, your data bills like got higher. Like, can you do something about it? Then you have like two options, right? Debug and check what's happening, or look for ways to make it cheaper. So, usually you tend to say, let's do it, like let's increase the budget for now just because until we solve it. And then suddenly, go, oh, DuckDB, for example, right? Because I tried to run DuckDB on some other processes to save, money on the Snowflake bill in one of the companies over before. Though when I understood that the problem I was trying to solve, doesn't matter what tool you're using, it's still gonna be bad. So like I'm going to give an example, right? What I tried at first. So we had a Lambda function that actually was like getting the event date, right? And it just pushes down to S3. And then we're actually reading that JSON file. So one message, one JSON file. I was like thinking, yeah, Snowflake takes longer because, Snowflake under the hood, what it does, each core or like each like node they assign you for that specific warehouse, it opens a file, reads its content, pushes it to the table, opens next file and does it in parallel. For example, if you're using XS warehouse, it has like 8 cores, I think. So basically, eight things are running in parallel. I thought like, yeah, we have Lambda, maybe we can actually push it down. But I did it in so retarded way that actually, I didn't thought about it actually, to read many files, like many small messages, right? And then, yeah, like DuckDB will aggregate it. Like at that moment, it didn't occur, that actually the problem is small files problem. Like it's a problem for anyone. It doesn't matter if you're DB engine, right? It's by nature the biggest problem in engineering in general. And I was like, okay, so that's not going to work. And it's like, okay, I need to look for other solutions. But in the end, I ended up just like, okay, let's increase to S. So we have 16 now.
Yes, but I think it's really important to emphasize that 10 years ago, if you went to a meetup, it was all about, let's reinvent the data model. Let's think of your data maybe as a graph or maybe as a document. And it was also about scalability. Let's scale to like humongous amounts of data sets. And these days, it seems that the mood has shifted a bit. And the hype technologies like the data lake techniques, and I would also say DuckDB, are more about saving money on storing your data and processing your data, and also making it available in an open format so you don't get locked in by vendors. So I think that's quite interesting how the sentiment has moved.
Mm-hmm. Yeah, talking about vendors, like I guess, what they also before recording podcast, like I wanted to actually understand what's the difference about MotherDuck and DuckDB Labs, right? So I guess, for the listeners, I guess that's also important to, draw the line where one is and another.
Sure. So DuckDB was born of the observation that you can use a database as a local system that runs in process with your client applications. So you have a Python process, you say import DuckDB, and then you can start firing your SQL queries right away. And this is very simple operationally. This makes the setup trivial, and it's a piece of free and open source software. But of course, there are situations where you need an actual cloud data warehouse, where you want to share data sets with your colleague, where you need security, fine-grained access control, better scalability, and so on. And MotherDuck is doing this on top of DuckDB. So they take DuckDB and they build it into a cloud data warehouse. And while doing so, they also invent many clever operations like this dual execution where you can run part of your query in the server and the other part, maybe the privacy sensitive part, locally on your laptop. So you have two DuckDBs working in tandem and communicating over the wire.
Okay, so that's that makes sense, I guess. To clarify for the listeners, it's very similar. Like I also verified this before with Gábor, is that actually very similar to what's Airflow and Astronomer. Like basically they work in a similar ways. So, since we talked about your journey, like how you ended up at DuckDB, we understood, what's the difference about this. So what do you actually do? Because roles, for me personally, I've seen them on LinkedIn, writing different things. It's a bit harder to understand, what they actually do in a way, because it depends from company to company, right? So what do you actually do? How does your day-to-day look?
All right, so DuckDB Labs is a startup company in Amsterdam, and we are about 15 to 20 people, and we are very technical. So we don't really have a marketing department or people doing marketing. We don't have sales. It's mostly developers, and then I am there as the DevRel to communicate with the outside world. That includes running our social media sites, writing and editing our blog, working on outreach, like this podcast. And a large chunk of my time is also spent on triaging issues. So I have all the incoming GitHub issues. I try to reproduce them. I try to help users solve their problems by upgrading their DuckDB or tinkering with the settings a bit. And then arguably my biggest task is the documentation. So what I realized is that I can travel around and give talks about DuckDB, but the biggest impact I can have is just plainly improving the DuckDB documentation. So that is an ongoing task of mine. And it's actually more of an evolving field than I thought, because now that we have large language models, the way people interact with documentation has changed. So there are quite a few considerations that you need to take into account when you're writing the documentation that ultimately will be read by a human, but probably with a large language model in between.
So any plans for you to actually, try to incorporate LLMs into your workflow? Because I assume, it would help, but it would create some, like, another check wouldn't hurt, right?
Right. So I am not really relying on LLMs. I would say the documentation is still hand curated. Obviously, I use the tools for spell checks, and I sometimes throw in text into ChatGPT and ask it to review it. But so far, the model is that the text is still hand-curated, and it will be consumed on the other end, maybe by an LLM.
Okay. So, like the fun thing is that I understand you're basically, you're kind of the product person in a way, right? Because you're listening to the users, figuring out their pains, then, prioritizing things and looking from, what you mentioned, that all of the people are like technical. So, like, I do assume, that you're the most extroverted person. Like, coming from me, like, I tend to think of myself as an introverted, and like talking to people is not my jam usually. But then, when it comes to your role, you have to be the one who actually conveys the thoughts and the ideas behind what the developers thought and what you agreed, to the actual larger masses here.
Yeah, I don't necessarily think of myself as extroverted. I think of myself as someone who has maybe a larger breadth than depth. So I'm interested in very many things. And this is something that tends to work out really well at DuckDB, because on the kind of superficial level, DuckDB is a very simple piece of software. You have a SQL engine and you can deploy it in all sorts of ways. But what we found is that the surface area of the DuckDB project is huge. And this is because we have to read all sorts of file formats. We have to interact with all sorts of protocols like HTTP, all the cloud buckets, all the cloud vendors, and so on. And there are all these security considerations, deployments, packaging, and so on. And I am quite passionate about computer science, and all these aspects interest me to some extent. So this is something that always keeps me like curious and kind of stimulated.
So basically it allows you to understand the, like, let's say on a broader scale, right? You like you mentioned, you're looking wide, while your colleagues can like focus on the deep technical things and like tinker things under the hood to make it actually work in the way it's expected. You mentioned, like, and I also, asked about, like, since you're talking about with users, checking their issues, trying to reproduce them. Any like super interesting ones you have, like, like, let's say interesting, crazy, or like unexpected uses of DuckDB?
Right. So because DuckDB is so portable, we do get a bunch of difficult issues every now and then. So a couple of years ago, I triaged an issue that was run on a MacBook PowerBook or a PowerMac G5, which still used a PowerPC architecture. And because the endianness of that CPU is different, it's a big endian architecture, it was broken on the indexing of DuckDB. And unfortunately, we did not have the cycles to fix that. But we have users who use DuckDB on FreeBSD, users who run DuckDB on the RISC-V processor architecture. So those can all yield issues that are obviously not possible for me to reproduce. I don't have access to RISC-V hardware. But it is interesting, and this is not something that would happen if you would run a cloud data warehouse where the hardware is a lot more constrained.
It sounds to me like, the versions on the hardware is sometimes, the thing that you actually have to, like, not to be ignorant, that you have to ignore because the impact is so little and you have so many other things you have to focus. So you have to just put it somewhere. Sorry, we cannot deal with that. Are there many of those requests, or how often do you have to say, that no, it's not going to be fixed?
Definitely, we have to say no. Sometimes it's just a matter of scoping down the project. We have a policy that we try to fix all the crashes, segmentation faults, and internal errors that occur in DuckDB. So if someone reports them and it's in a good reproducible report, it's likely going to be fixed in the next bug fix or the next minor release. There are many features many issues that are basically feature requests. So sometimes people have really convoluted queries and they run out of memory. And indeed, we could do an optimization that would prevent them from running out of memory, but that's probably a multi-week undertaking for one of the engineers. So those usually get labeled as feature requests and go on the back burner.
I was one of the questions. So I just thought of so does it make sense for you to actually add some specific optimizer, or let's say some specific engine, like you mentioned, it's a feature request in a way, right? That would actually suggest to user, to write his query in a different way, like in a bit more optimized.
Right. So this came up quite frequently, the idea that we could provide hints on how to optimize the queries, but doing so in a general way where this is done in an automated manner by the database, that is a very hard open research problem. So we decided not to do this. What we did instead was to create a part of our documentation that's called the performance guide. And this is basically based on our experiences and the lessons that we've learned, a long list of things that you can try, some knobs that you can tune, and some obvious best practices to avoid.
Okay, so I guess also one of the things about the performance, like you mentioned performance guide, also educational part would help there as well, because I guess bad habits die hard, with SQL especially.
Yes, especially. So one of the things that I always explain to people is that if you learn databases in a university setting, you were probably taught B trees or B plus trees and how you should use them to make high selectivity queries work, and also primary keys and foreign keys work. And this is all great if you're in a transactional environment, but it is rather counterproductive if you are in an analytical environment. So the performance guide in DuckDB has examples on what happens if you add the primary key. Well, loading the data will be slower and the queries will not be any faster. So this is something that you should probably avoid. This is something that you have to unlearn with DuckDB.
So DuckDB has indexes?
DuckDB has indexes, so it has built-in min-max indexes in the columnar storage, and that's usually sufficient for 98% of the use cases. But you can also do a tree-based index. It's called ART. You can define it with the SQL standard create index, and this will help the queries where you just have to select maybe 1 out of 10 billion entities. Then it's worth doing it. But otherwise, this is something that you should avoid.
It actually makes sense, because usually DuckDB is not going to be used for, queries like this. It's going to be just give me min-max or some, on the framework, time frame from this to that, and that's it. Okay, so I learned things that about DuckDB, and that's already going super great, and another thing, is that since we're talking about SQL, natural question is that each time, you see some language, like, some different approach. We had like NoSQL came out, right? SQL is going to be dead. Everyone is going to move to NoSQL, right? Then, Spark came out, like with, now everyone is going to be using data frames instead of SQL, and this SQL is going to be dead. And we see, this pattern, some new technology goes in, right? Everyone is on the hype curve, Then like, yeah, this is gonna die, SQL is gonna die. We're gonna actually move from this to that. There's tons of migrations, and suddenly, like everyone is shifting back to SQL. So since DuckDB, is actually a SQL engine. So my question to you is, what's your thought on this? Is it kind of part of the cycle you mentioned in IT, or why, and in general, why people are dishing on SQL?
So this is definitely part of the way innovation happens in IT. And I think overall SQL is a good language, but it's definitely easy to find faults in it, and it's easy to find missing features. Especially this was the case 10, 15 years ago when it was really not moving quick enough to adopt things like nested documents. But in general, what tends to happen is that people find a bunch of problems, like they realize that SQL is bad if you want to do path queries in a graph. So SQL has something called with recursive, but this is a very convoluted and difficult to write way of formulating path queries, and it's also not very fast. So people say, okay, this clearly doesn't work with SQL. Let's build a bespoke query language that caters just for that. In the graph space, there was a query language called Cypher, CIPHER, that was pioneered by a company called Neo4j. And this does all the graph traversals very neatly in a concise syntax. But the problem is that once you're done with your graph pattern matching and graph path queries, you realize that you still need all the bells and whistles that SQL had. You will still need aggregations, you will need window functions, you will need all those conditional constructs that are in SQL, datetime support, and so on. And at that point, you're at a crossroads. You can either take your GraphQL language and add all these features into it, which is a massive engineering undertaking, or you can take an existing system and try to bolt on some of the features, in this case, the graph features. And I have spent about 10 to 15 years in this graph space, and it's playing out in an incredibly interesting way. There are two languages. One is called GQL for GraphQL language. This is a standalone ISO standard language that follows the path of let's create a new query language and add all the features to it. And there is a SQL extension that was published in the SQL 2023 standard that's called SQL PGQ for property graph queries. And the jury is out there on which one of these will actually be successful. So this is something that is unfolding real time, and it's, I think, fascinating to watch.
Is that extension is kind of like, I do assume that most of the extensions that are being written, they're aimed at Postgres.
So there is an effort to create a Postgres implementation for SQL PGQ. There is a DuckDB extension that does it that I was superficially involved in when I was at the Research Institute. But there are also a bunch of systems that support the standalone GQL language.
Okay. Since one of the things, is like the specific use cases, right? Why people are dishing on SQL. Like, what do you think about the syntax in general, right? Because it's not that intuitive, you have to select this from that. It's like naturally it would say from table here, select this and that, where it goes. So like, I do know, that actually this, like, it was formulated or created in the way back like very, very long ago. It was like 60s, 70s, somewhere there, right? And then basically, it just became a thing, and then no one wanted to actually change it just because of how massive, the impact would be. So coming to DuckDB, when you're in, creating an engine, right? Did you have any thoughts on actually, maybe adjusting this? Because I know that you have some of the features, how you can query it a bit differently.
Yes, so DuckDB has a bunch of extensions and optional changes to SQL. We use the umbrella term friendly SQL because these make SQL a bit nicer to use. And one of the favorite of users is the from first syntax, where you can say from this table, select star. And you can even omit the select star, and then DuckDB will just substitute that for you. So this is already one way to make the working with the query nicer. Another fan favorite is group by all. If you have an aggregate query, you select the student ID and then the average of their grades. Then in most SQL systems, you have to repeat that you want to group by the student ID, which is completely superfluous. The computer could figure it out for you. And with group by all, it does. And group by all became so popular that almost all of the other vendors like Databricks and Snowflake, they have adopted it in the couple of years since it came out. But I think one of the difficulties with SQL is just how difficult it is to compose queries. So if you just want to do one query, then either you can do subqueries or you can do common table expressions, but they tend to make debugging and writing the query convoluted. So one thing that works really well with the modern generation of SQL databases like DuckDB is just to use repeated create table statements. So you create a table, say create table something as, and then you do a query. And sure enough, you have to write that usually back to disk, but it makes your queries a lot more easy to inspect, easier to debug, and it's just a nicer experience.
True. I guess, like I did my part of, debugging of queries and actually followed the same scenario. It doesn't matter what the engine, like I'm just extracting the CTE, like making it as a table, using it lower it like down the stream, rewriting the query in this and seeing like where it actually mismatches, because like otherwise you have to comment out the CTE name with the parentheses, then you have to actually figure out if all of the other CTEs are working or not, what you can use and not. It becomes very, very tedious thing. So actually it makes sense. Though talking about the like the CTEs and these things, right? So I do think that still writing to disk is good for debugging, right? Because you can also, by the way, you can also create views that actually does the same scenario in your case, right? So I guess it's a matter of choosing the right principle for you, because there are two schools of thoughts, let's say, right? The subquery guys and then CTE guys, and they're like, no, this one's better, no, this one's better, right? But does it actually matter apart from debugging?
No, so one of the innovations of DuckDB is that the subqueries are handled quite neatly. When I learned SQL 15 years ago, people told us not to use subqueries like exists or not exists and just do a manual rewrite into anti-joins or semi-joins. It turns out that this is, again, something that the computer could do very well. So DuckDB can unnest these subqueries and fold them into the query plan quite efficiently. So with DuckDB, it doesn't really matter whether you want to do a common table expression or the subquery, or you can formulate it in a single query with the joins yourself.
Oh, really? Like when I was starting SQL, when I was learning things, like one of the things, that they said like to use, is like select one from this, and then, in the where clause, do the like with the exists one. And like I was like, oh, it's super neat because, they said that it hits only once. If it finds anything, it's already okay. And now you're saying like it goes against like my brain explodes, because actually it's a bit different from what actually like. I do assume, the reasons why, because someone checked on some specific scenario, it works well. So the natural assumption that it will work well everywhere, right? In your case, since you've been doing, the internals of databases, like tweaking, fixing, and checking how it works and whatnot. So actually I have to now do my research, actually, how to actually write it, because I haven't used exist actually when I left MS SQL.
Yeah, but this is, I think, in general, a good advice. You can run your own benchmarks, and this is where all the ease of setup and ease of getting data in comes in. If you have such a question, you can probably devise an experiment in literally a matter of minutes, and then you will see that you either get identical runtimes, in which case you can drop the old habits, or you can indeed observe some of the differences still.
No one is going to drop old habits. Old habits die hard, right?
That's true.
And another topic that I actually wanted to touch in a way is that, the WASM is getting, traction, right? We see a lot of things like that. So browser analytics.
Yes, so this is kind of an unexpected thing in DuckDB. This is definitely not what the creators of DuckDB had in mind when they embarked on this journey. But it turns out that because DuckDB is a very lean C++11 code base with no external dependencies, you can actually compile it to the WASM platform, and then it can run within your browser. Now, why would you want to run a full-fledged database in your browser? Well, it is very popular, for example, for dashboards. So there are a lot of dashboard software used for BI use cases and decision support, where you need to render some sort of a diagram. And sometimes that includes some last mile analytics, where the server did most of the number crunching for you, but you have to do the rest locally based on the user settings. And there were, of course, workarounds for that before. People have used dashboards before DuckDB WASM. One was that you can do it locally with some JavaScript. You just do some for loops and some if statements for filtering, which is not very fast. And the other alternative was to send it back to the server, make the server do the number crunching. Now that alone is fast, but you lose time just round tripping on the wire. So people put DuckDB into these dashboards, and they reported this really interesting psychological effect that you did a click and then you get an instant change in the data. And that was a bit weird because they were kind of expecting the machine to take a deep breath and then deliver the results. But this is happening instantly. We call it video game style dashboards.
Ah, nice. Yeah, and like why I asked is, that I saw some tutorials where people were using, I'm not even I might be mistaken, but I think like people from Snowflake even, suggested, when you're building Streamlit apps, right, you can use, like DuckDB for, faster. So basically offload some of the data, from Snowflake to S3, you connect everything through DuckDB, and you have like everything running smoothly and way faster just because of actual, less data to process, and DuckDB is lightweight, so you can have like very fast and efficient dashboards, like with a couple of clicks or like couple additions, instead of constantly querying Snowflake for actually inducing more and more costs. Any plans, to actually, I don't know, do something crazy apart what you have now, right? Because like as I see, the like capabilities in analytics, they're like not that limited. Let's say you can find multiple areas where you can improve. You can find multiple use cases of users, right? Which areas you can tackle. So maybe something crazy is also on your roadmap apart from what you already mentioned.
Yeah, so the tagline for our upcoming roadmap is the multiplayer story of DuckDB. So we want to make sure that you can work on the same data set with multiple DuckDBs in a concurrent manner. Mm-hmm. And obviously the data lake technologies are a huge help in that. And also this really strong enthusiasm and momentum that is behind the data lake technologies is something that really ties into this. So this is what is mostly on our roadmap for the next year.
Okay. So actually, it kind of makes sense, I guess, since you're aiming to allow all of these to like basically replace in some cases, some of the like more scattered technologies in a single place, which would actually, help people do things way faster and locally. And fun thing is that about the committing to the DuckDB, right? Since it's C++, right? How hard or how easy is for people to actually, instead of, just opening issues, like opening an issue and attaching a pull request to this? How does that process look like?
So it really depends on the scope of the issue. We are in general really happy to accept bug fixes and small features. For example, if you miss a particular regular expression matching function that is there in Postgres or is there in Snowflake, we are really happy to accept it. The problem is with larger, more overarching changes. If someone wants to introduce a new optimization, a new operator, a new SQL feature, it's usually best to talk to the development team, because this may be something that we already have in mind and we have our idea on how we want to do this, or this is something that we considered but then decided against it because we don't want to maintain that particular code. So we always say that to avoid heartbreak, it's best to open a GitHub discussion first, get a bit of traction for it. There is an upvote mechanism in GitHub discussions that allows us to gauge the community's reaction. And if something is popular and someone is willing to implement it, then we can discuss it, and we're happy to review pull requests.
So how often does it happen that actually people go code first, ask questions later?
It is becoming increasingly rare. We have made it clear in the contributor guide that it is going to be difficult, and the code base is also quite fast moving. So it does happen that someone opens a pull request, they get a bunch of feedback, and as they are working through the feedback, a bunch of merge conflicts get introduced. And that is, again, one more way to get heartbreak, because then they either abandon it or they double down and they spend a lot of time resolving those merge conflicts. It is difficult to contribute to such a fast-moving database project like DuckDB.
Yeah, that's fair. And since you mentioned that it's in C++, I guess, that's one of the obstacles where it limits in a way, people contributing, because I don't think, that C++ is very popular in general. I think game dev, are actually using C++. Some of the other, like ClickHouse, I think is in C++. And when I talked with one of the people from there, did an episode on this, they said like that's a bit harder. But, mostly talent is like somewhere in the Eastern Europe, actually, just because, so how the situation is for the committers and actually finding good people to contribute to your code base.
So interestingly enough, C++ is usually not the limiting factor. I mean, surely it's a challenging language to use, but we don't observe that as much of an issue, especially because we use a reasonable subset of C++. So it's C++ 11, there isn't really too much craziness going on. The difficult thing that we have seen committers struggle with is getting their commits and pull requests through the CI. So we have elaborate tests in our CI, and we build DuckDB for this matrix of different platforms like ARM64 and x86, operating systems like macOS, Linux, and Windows, and different clients. And it is easy to introduce subtle issues that will only surface on one of these platforms, and that can lead to difficult troubleshooting times.
Okay, actually makes sense, since you already mentioned the problems on different architectures, right? That people working locally, they most likely won't get that reproduced. So talking about the tests, right? Do you have any tests on benchmarks? Because I do understand that if you make some changes in your, in some specific places, or like how the engine executes, it might impact your benchmarks in general, right? That's how also the community, how it sees, the tool. If it performs on the benchmarks not that great, then they start raising questions and whatnot. So how do you do that?
So that's an excellent question. In our day-to-day commits and even in the nightly builds, we only do functional testing, but we have introduced weekly regression tests where we actually spin up a big EC2 instance, and that runs TPCH scale factor 100, TPCDS scale factor 100, and a bunch of other benchmarks. And then our development team gets the reports from the GitHub bot, and it states whether there has been a regression. And of course, we take regressions very seriously. We don't want to be a fast engine that's just getting eroded away commit by commit.
I guess you can also, see, like that with some of the releases, let's say nightly builds, it goes down, but then suddenly next one is, you got the error, fixed it, and it's back up again to where it was before, even better. So that actually makes sense.
Yeah, and there's a fair bit of noise, of course, in all these measurements. So it's a bit more difficult than I initially envisioned.
But I do feel, that the noise is mostly, related on some specifics, because it's still locally, right? You don't have any network, I guess, issues, because as I understand, you just load the data set to the machine you just raised. So locality works in a bit different way. You don't have like network issues. Let's say some, in the data center, some cable is faulty and whatnot. So that doesn't happen, but nice. Yeah, so I guess, I'm out of questions. Had very nice talking to you, Gábor, about, DuckDB. I'm super excited about your keynote today. So thank you for joining me in this fun conversation about DuckDB. I learned a lot, actually.
Thanks for having me. And yeah, looking forward to the chats in the evening today.